Once again, this is Ham's Consulting Inspection. We're gonna discuss today mechanical system inspection regarding uh, construction for newly installed piping system in the building or residential. So this will be my fourth video on the under mechanical system inspection, and I add some scope for the today discussion. So this will cover as much as I could uh, in regards to the photo that I'm gonna share and some code uh, standard that reference the testing that I have observed. So the scope will be this scope for today's discussion will be the HVAC mechanical system side, the hydronic piping, pressure test requirement, uh, and the details, procedures, and observation I will discuss. So the purpose of this type of inspection and testing is to my fellow inspectors. So it's additional, especially if additional information. So especially if you're just starting to do inspection for new guys. So this is to familiarize with the item, the details to do verify on the job during the inspection. So and to be aware of the requirement of each piping system. So each piping system has different categories. So we have refrigerant pipes, we have chilled water piping, steam piping, low pressure, high pressure piping. For usually for residential and building, we only had low pressure pipe system, steam steam piping system. So and some also hydronic piping for condensate piping line. So it's like the uh, change of energy. So condensate and super hot water piping will have interchange of temperature. So it's a transfer of energy in both of the system. So and yeah, also the purpose of this kind of testing is remember, this test is for only for newly installed piping. So if you have an existing building and you're only adding a new piping system for let's say a split type unit, so you're gonna run a pipe along in your ceiling or in your wall. If you ask a contractor to do it, so for the system to be in compliance with the installation, you need to pressure test it so that to prevent some leaks on the connections. So after the full installation of the system, this is a industry standard that you need to test every pipe so that you don't want any leaks on the ceiling or in the wall before they close it out. So and we're talking about the future. So if after construction, all the piping hasn't been tested, and after 10 days, a year or more, or 5 years or more, if all installation is not properly tied, so this is gonna uh, create a problem in your building or at your home. So, okay, so let me share some photos. Have taken the job. Let me go back. So, the system I'm showing here is uh, an assembly for steam piping. So, the test should be as should be observed for 2 hours. So that's code requirement standard for every hydronic piping system. So during the 2 hour test, you took a photo of the whole assembly where your pressure gauge is installed. So that's the setup of the test, and you need to identify the reading of the pressure. So we're gonna discuss the required pressure for each particular piping system. So during the test, you need to visually verify if all joints connections are totally leak-free. There's no drips of water. There's not bubbles of water outside of these pipe surfaces. So during inspection, take a photo of the whole assembly where you taken the test setup and the pressure gauge. Uh, this is how you're gonna know what the test pressure is. So this is like 240, above 240. So each line represents 5 psi. So this is 200. This is 225 psi. 250. So this is around 240 or 242 psi. And then one thing to verify during the test, first and foremost, you need to have the pressure gauge that you're using for the test is calibrated. So you need this is like a quality assurance or a quality check for the pressure gauge. If your gauge is really reading the amount of pressure that needs to be used. So the calibration certificate should be available on the job, and you need to ask the contractor or the master plumber to provide the certificate of the gauge so that we are really using an an accurate gauge for the system. So you have a calibration date and a calibration due. So in this case, this inspection that I did is way back between this year. So it's like year 2020. So this is a year of calibration. So it depends on the pressure on the calibration certificate. If you have sometimes some calibration lab, they do it every 6 months, and some other are a year, and some other equipment they usually calibrate it to up to 5 years valid. So it expires, the calibration expires regardless if uh given that I mean given that the gauge is totally is not broken. So as much as possible, if you're witnessing a test, some building departments they usually go on the job site before they pressures the system so that they could see this dial to be 0 for accuracy, and after the test they need to drain it out, and that dial arm should be go back to the 0 again, so that it means he was reading the correct pressure that will be used for the system. So that's part of the procedure that we usually witness and verify. So for the pressure that we are using, so this is a 2 hour test. I taken the photo at 9:38 and then taken the photo at 10:29, a screenshot. So the pressure didn't drop at all after an hour. And then at 10:30, still the same pressure. So let me go back on the pressure that we use. So this is 200. If it's a steam pipe system, steam piping system. So let me share some and pull up some code standard in reference to our discussion for today. Mhm. One. So I'm using New York City mechanical code. So it depends on which city are you inspecting. So on my case, I'm doing the inspection job in the great city of New York. So I'm using the building code or the New York City jurisdiction requirement for each uh, uh, job, the required code reference for each inspection. So this is under mechanical chapter 1208.1, the general. So hydraulic piping system, other than ground source heat pump tube system. So other than, so shall be tested hydrostatically means water, hydrostatically at 1.5 times the system design operating pressure, but not less than 100 psi. So, and the duration of the test shall not be less than 2 hours. So, so I believe the system that we're testing is like more than 100. That's why we are testing it to 240 psi. So should not be lower. So if in case we're doing because sometimes I'm gonna witness some system modification. They're just gonna install a new piping system and will be attached on the existing system. And sometimes some existing system is operating at 5 psi only or 10 psi. So the contractor will say if it's 1.5 times the operating pressure. So for 10 psi, we should only test it for 15 psi. So it depends on the situation. Because I always tell them if it's a new pipe, we only need to test the new pipe and we should isolate the existing piping system so that we're not gonna blow it up, burst some connection on the system because it's not part of the job. So if it's a new piping system, regardless of the operating pressure, it should not be less than 100 psi. So if in case it's attached to the existing system, the new piping is attached, connected to the existing system, and you cannot test the whole system as a new piping. It might create some leaks in some other, let's say if you have 10-story building, 20-story. So if you're only renovating one floor, it will, if you're gonna test the whole piping, it might, and you don't know how long this building has been existing for maybe 20, 50 years. And if you're going to test the whole system, it might leak somewhere else, and you don't want that to happen. So in that case, you need to uh, refer the attention to the building engineer, or unless the contractor could isolate the new piping to be tested at 100 psi. Yeah, so that's the case. So it's a case by case basis. So let me sidestep ground source heat pump loop system. So this is other system that I could share also on this discussion for today. So I just searched for this ground source heat pump system because I keep on asking what kind of system is this. So upon searching in the internet, I saw some images that looks like this. So it's a ground source heat pump system. So this is, yeah, it's using the Earth's temperature for the water. So this is only one line. The water will travel on the ground, absorbing its heat to heat up this heat exchanger. So this water, cold water, will go on this system, like it's a coiled coiled type system that will have a heat transfer between the hot temp and the cold water temperature. It will, when it comes out to this heat exchanger, the temperatures is higher from the inlet. So this will supply where you have the hot and cold water in your shower, in your faucet, and even in your radiators. So, and on the job site, you could see something like this before they backfill the piping on the ground. You need to test it, uh, uh, test test it in a required as required, like ground ground source heat pump loop system. So the assembled loop system shall be pressure tested with water at 100 psi for 30 minutes only. So and so on and so forth. So flow and pressure loss testing shall be performed. So and so on and so forth. So that's the system, and this also one line. So I believe the blue line is the cold water, and then it's gonna run, absorbing the temperature of the ground, and it's become hotter when it go back to the building. So it's red, means hotter. And this is two system that is running. So this one, I believe this coil and this horizontal collector will absorb the temperature, the hot temperature of the ground. In this case, this one will absorb the temperature, the cold temperature of the water from the fund. So this is a two-way system. You have cold water, or unless it depends on the temperature of the water that you're getting at. So you see the arrow, this is a cold water coiled up and observe the temperature of the pond. If it's hot, so you have a red line going back, cold water, red line going back. So it's hot water going back. It will uh, go to your plumbing system. So, all right, and go back. Getting back to our previous main discussion. So this is the pressure gauge, and this is another system. I believe this is the low side of the steam pipe. So this is like the condensate side of the steam piping system. So we got lower pressure. This is only reads 109 or 108 psi only. So this is a different pressure, operating pressure. So that's why we're testing this for a lower pressure. And then we have the chill water. So the steam pipe is for the hot air for the building or your home. So during winter, you're gonna have a hot air, so this piping system will operate. And the chill water is for summer time, so this will operate during summer. And the steam piping will be shut, and during winter and during summer, chill water will operate, and vice versa. So I believe this pipe is looped together so that we're only put only one pressure gauge. So what I mean to say is if it's looped together, it's connected to each other at the other end of the pipe or in the unit. So we're only observing the pressure at one side of the pipe because this pipe is connected to this also. So we're testing it as one system. But it should be when it operates, it should be the supply and return. So upon reading the pressure, we have 240, between 240 and 245 psi. So it's like 243 psi. So for this pressure, this is a chill water pipe. And I will discuss that later on as we go on with the photos, because my photos is organized by the way I observe it during inspection. But in that case, just gonna pull up some code for refrigerant piping required tests. So at this section, we are testing it for refrigerants, so chapter 11. And the field test is chapter 1108, field test for chill water piping is that shall include the low and the high pressure side of each system at not less than the lower side design pressure of the setting or the setting of the relief device. So, so it depends on the setting of the relief valve of the system. So, ano sabi mo? Ano ka ba? Nagre-record ako. Close it. So later on, we are testing later on I'm gonna show the nameplate of the unit so that we are not, and the pressure that we use is not insufficient, it's not lower than the low side design operating pressure. So this is the whole code right here, and that's the exemption if you could read. And let's go back to my photo taken on the job. So bear in mind this is 240 or 245 psi pressure for chill water. And a side step on our testing observation, this is also part of the job. So the contractor, I think they asked me if this ductwork penetration needs to be protected, or because it's a new duct and it's a existing wall. So as per code, they need to restore what was the previous rating of the wall. So if this is a fire rated wall, you need to have a fire caulking around it, around the around the ductwork. So this gap is unacceptable, and those penetration needs to be parsed up. Or in case if this is a fire rated fire rated wall, I mean, sorry, you need to have a retaining angle and a fire damper, a protection inside of the duct, so that it will prevent the spread uh, of fire or smoke on the other side. So it's a prevention for the fire to spread quickly. So that's a side step. So I'm not gonna discuss. That's another inspection category. Going back to our main discussion, this is the system. This is the new equipment that we are testing. So I believe so the others, this is looped together. So it means it's connected to the unit. So it went in and went out. So this is looped together. So that's why we're testing the whole system, including the equipment. So for that's this another information. So it doesn't really necessary to test the equipment during this kind of testing, because we're only testing the newly installed pipe outside the equipment. All this equipment has been pre-tested by the manufacturer. So this equipment they don't need to include it to the test. They need to isolate it from the new piping that we are testing. But So, but in this case, we are testing it at an acceptable pressure. So I think the equipment could handle the pressure, but not necessarily need to be included on the test just in case, because anything happen on this equipment, it's gonna be on the contractor side fault. They need to replace it if they ever have uh, broke it. If the pressure is too high and the equipment cannot take it, it might have a problem inside of the unit. So that's an extra precaution for the test. Okay, so in this case, I think the pressure drops. Remember, we have 240 or 200, between 240 and 245 pressure. Now it was like 230 and 235 between, so 232, roughly 232 psi right now. So it was like it drops like 10 pounds, 10 psi. So I think on the next photo, we did retest this one for another 2 hours. So they did pump it up. But before that, we went back to our previous steam piping test. So the original time that I have in here is 10:32, and then I have screenshot it at 12:32 after 2 hours. So the pressure is like 100, 108 or 109 psi, is like less than 110. And then the next photo is 12:32. So I taken the photo again at 12:32. At 12:34, the screenshot is 12:32. So the pressure stays. It means the piping system is totally leak free. And if there's no visible leaks or drops in the floor or in the joints connections, so it means this piping system is free of leaks. So it's perfectly tight. So that's the low side of the steam piping. And this is the time that we have pumped up the chill water piping. So right now we are like exactly 240 psi. A closer look. Oh, this is the steam pipe. So this is taken to 12:40 p.m. and then at 2:27 screenshot, the pressure was still at 240 psi. So after 2 hours, now it's 2:45, still 240 psi. So it means the pressure, the system, the chill water piping is leak free, no pressure drop, and no visible leaks. And then, okay, so this is the drawing details for the equipment installation. So, so that's the condensed water, the chill water, uh, and in and out. So, and verify the equipment that is required for the installation. We got the condensate pump, the concrete housekeeping pad, auxiliary drain fan, water sensor, and gonna have a vibration isolator. It's like a neoprene pad only, so it's like a rubber that's will absorb in case this equipment vibrates. It's not gonna make any noise. It's not gonna make it's not gonna break your concrete pad. So for the absorption of the vibration. So this is your pump, just in case you have flooded this auxiliary drain pan, condensate pump, and you had the flood sensor. So the purpose of this is when you have a flood and if it's gonna spill out right here, it will stop the operation of the equipment to prevent flooding, or I think this will operate the condensate pump to throw out the excess water in the fan. So, and this is the nameplate. So remember in the code we had says that every refrigerant containing part, every system that is erected in the premises except compressors, condensers, vessels, evaporators, safety say devices. Oh yeah, you see, except those equipment that is tested by the manufacturer. Safety devices, pressure gauge should not be included in the test are listed. So that's except. So refrigerant only containing part that is erected in the premises shall be tested to prove tight after complete installation and before operation. So test shall include the high and low pressure sides OP system at not less than the lower of the design pressure or the setting of the pressure relief valve. So the design pressure for testing shall be those listed on the condensing unit compressor unit nameplate. So that's your reference point where you're gonna find your pressure to be used for the test. So it's the nameplate of the condensing unit. In this case, this is the nameplate, and this is the design pressure, low side and high side. High side is 600 psi, low side is 236 psi. So I believe we tested it to 240, the second test, after the first test has failed. So we pump it up. We observe it for 2 hours at 240 psi, so it's not lower than the low side design pressure of the condensing unit. So we are in conformance with the code, and the system is leak free, no pressure drop, and no pressure and no visible leaks on the piping connections. So that's one test. That's for chill water. And let me share some for refrigerant also. So after testing, I have found some requirement that I could share also under refrigerant piping test. So this is one of the requirement. The system shall be pressurized for a period not less than 60 minutes. So it's an hour test to not less than the lower of the design pressure. So it's a pressure test, not lower than what was specified on the nameplate of the condensing unit, the nameplate condensing unit. So it was stated right here, and the test medium was also. So after that, some job we need to have a vacuum test for 500 microns. So this is a negative pressure. They have a particular gauges for this to be used. So we also need to have a calibration search for that particular pressure gauge. So this is a vacuum pressure. This is another test requirement in case your job requires it. So this is the requirement. And that is the tolerance shall not rise above 1,500 microns for a period of 10 minutes. So it means if the refrigerant piping system reaches 500 microns, you're gonna time it for 10 minutes, and it should not be more than 1,500 microns after 10 minutes from 500. So it means the test is conformance with the requirement as per this code. So this is another thing to as reference. So if your refrigerant piping is running on the air duct, so this is more restrictive. So you got 150% of the pressure to be applied during the test. This pressure will be applied on the higher of the design pressure line or the pressure relief device. So another requirement I have encountered on the job, if ever you will encounter it also and you don't have the correct people to provide it to you. So this is the dehydration requirement. So this is a two-way test. After the pressure test, I have witnessed also the 500 microns, the first stage of the test, then a break pressure of 50 psi. So this 500 microns should hold for 5 minutes. No changes on the reading of the pressure gauge. And then the second stage will be 250 microns. With that, I think this is the gauge that we use. So what I did for this particular test, I always had a screenshot with this just to have a 5 minute hold requirement as per reference requirement of the job of the testing as specified by the engineer. So this is a negative pressure, vacuum pressure. In this case, I got original time right here like 1028 to 1032. So the pressure is 224 vacuum pressure. This is the first stage at 500 microns, so you need to be lower, as low as that. So we usually set it up to lower so that when it rises up and I have the 5 minute hold, I could say that's the passing requirement for the test. So in this case, this when I took a photo again, the pressure rises, means there is some leak inside the pipe, the refrigerant piping. So it's a vacuum test. In this case, I think this is a pass under 500 micron requirement. So at 736 to 743, I circled it right here. So it's like 7 minutes pass and the pressure still holds right here. So I believe this is the main requirement. So it will hold on a certain point that you need to comply with. 236. So a screenshot 743 and then okay. So I got two photos. When I take a screenshot is 743. The time is 736 at 286 vacuum pressure, 286 microns vacuum pressure. And then after 5 minutes, it was still 286 microns vacuum pressure. So this is a pass under 500 microns at 5 minutes hold, 5 minutes hold of the pressure. So it passed the requirement. So after that, we break we have a break pressure of 60 psi. So I did verify the 60 psi positive pressure on the system. And then we vacuum it again to 250 microns. So in this case, I need to hold the pressure also again, wait for the right pressure as it went up to have a holding pressure less than 250 microns. So, so that is some of the references that I have witnessed on the job, and that's uh, I believe the proper procedure to observe it. And so far, that is the discussion for today. So I'll see you next time when I have something new to share with. And please comment and share for additional information regarding inspection. Thank you.